uh, when we were discussing atomic radius, we mentioned two things: the nuclear charge, the shielding, and then the repulsion. I talked of these three things. This is nothing to do with orbitals because that affects the ionization. This is the total size. The total size is the total electron cloud. It is not about one electron. So don't keep these separate. The ionization effect factors which affect the ionization energy and the factors which are affecting the atomic radii or the ionic radii. When we talk of ionic and atomic, we talk of the whole charge. We talk of there are four factors in case of ionization: charge, distance, energy, electron pair, repulsion, shielding. Oh, they are also, but there now we are taking one electron, so we go look at the orbitals very carefully. Here we don't have to look at orbital like p, s. We don't look at them separately. We'll look at them separate together, and we will look at them. We'll look at the nuclear charge, we'll look at shielding, we'll look at repulsion. Not spin pair repulsion, but inter electronic repulsion. Now, what's the difference? Let me explain. First is, of course, the shell uh, uh, number also. So first, the nuclear charge. First pattern you observe is the atomic in the Na plus, Mg plus, Al plus, and silicon. It actually reduces the ionic. Now, this is quite obvious. There is one shell here, 3s1. It has gone away. 3s2. It has gone away. So one thing is the shell number is reduced. So here the shells have gone. In the cationic, you will say the shell is uh, the cationic radius, the shell has been removed. That's why the positive is less than the atomic radii. The ionic cation radii is less than the atomic radii. One thing. Second factor. You say the electrons have reduced. The protons nuclear charge is there, but the electrons has gone away, reduced. So proton uh, are more are more. So they hold them strongly. So the nuclear charge per electron has increased. Shielding, no effect, no shielding because these are this outermost shell, so no effect on shielding, and no, and repulsion is reduced because there are less electrons. So repulsion don't say spin pair because this the effect of all of them. There are less electrons totality may outside now, so they are repelling each other. Inter electronic repulsion is reduced. But if there are less electrons now and more protons and they occupy the same space, there will be less repulsion among the electrons. Now, there's a difference here in ionic. First, what has happened? In nuclear charge, uh, uh, the proton is same, but the electrons have increased. So proton is same in anion, but electron has increased. So now they are held less closely because here this had 15 proton, but it had 18 electrons. Three have been added to phosphorus. There were three and now there are six. So, so electrons held less strongly. Per electron, less force. So one reason, so they expand. Two, the inter-electronic repulsion more because there are more electrons in the same area. And three, the shielding is same. Shielding is constant. Even though the effect is not playing a part, you have to tell that it is not playing a part. You have to give a reason that it's not working. That effect is not working. So that's why it's constant because the inner shell are same, na? Shielding is only because of inner shell. The inner shells are same. So then you get complete marks. Let me show you the answer. Outer shell lost. Atoms uh have one more shell than corresponding ions. So they have got one. This has it lost, or he says, or effective charge is greater. In PCL, you say gaining electrons to the increased repulsion between. He not doesn't say inter. Spin pair repulsion. Okay, he doesn't say spin pair. He says increased reaction outer shell or p or subshell, and that's all three parts. So you understand, na? He's talking of, he's trying to cover everything.